I'm Sam, an OpenSciEd teacher and facilitator. This lesson is a bridge in the unit where we move from knowing plants contain food to questioning where that matter actually comes from. Let's take a look at how we got here. During the last lesson, we confirmed that plants have large food molecules like carbohydrates, proteins, and fats inside them. But we have many different ideas about how they got there or where they came from. In this lesson, we are wondering, do plants get their food molecules by taking them in? Let's take a look at a lesson at a glance to see how we'll get our students through this lesson. Before we dive into the flow, let's look at the logistics. This is a 2-day investigation lesson. It requires a bit of the longing for the prep. You'll need about 4 hours spread over 1 month to prepare and maintain the hydroponics plant system so it's ready for day 1. For the food indicators lab on day 2, plan for about 40 minutes of active prep time. These are all hands-on labs as you're preparing for, and devices are not required for this lesson. However, there are several teacher-facing videos on the OpenSciEd website to help you with the setup of both your hydroponics system, which is needed for day 1, and several more videos to help with the setup for the indicator lab on day 2. We are going to break this lesson into 3 big loops that take place over the 2 days of instruction. Let's zoom in on those loops to see how to make this lesson more manageable. Loop 1, which happens on day 1, is parts 1 through 3. We begin by looking at our plants and realize they've gained significant mass. We list everything the plant touches: soil, water, air, light, and even plant food, as a candidate for where those food molecules might be coming from. We figure out that plants contain food molecules they didn't start with as seeds. So they must be getting those plant food molecules from one of the environmental inputs. This leads us to investigate the inputs closest to the plant roots first, the below the surface candidates. Loop 2, which happens still on day 1, is parts 4 and 5. You're about halfway through day 1 now. In this part, we analyze a hydroponic system where plants are growing healthy and strong without any soil. We figure out that since plants can grow without soil, soil cannot be the source of food molecules, which leads us to wonder, if it's not the soil, it must be the liquid they're growing in, or the plant food and the water. Loop 3 happens on day 1, at the end of day 1, and takes all of day 2. It's parts 6 through 9. In this part, we examine the plant food labels and use chemical indicators to test it for carbs, proteins, and fats. We figure out the hydroponic liquid and the water contains 0 food molecules, which leads us to wonder, now what? If it's not in the ground or the water, where else could we look? So to summarize, on day 1, we figured out that plants can grow without soil, which means soil is not the source of their food molecules. And on day 2, we figure out that the water and plant food added to the hydroponic system contain no whole food molecules, meaning plants aren't taking in food molecules from the ground. Let's take a look at some key moments that we can make as teachers to help this lesson run more smoothly. The first key moment takes place on day 1 in part 3. It's where we create a list of our candidates. The purpose of this part is to turn our general wonder about plant growth into a specific checklist of candidates. By categorizing our inputs as below the surface, we can create a more manageable investigation for our students. In parts 4 and 5, which are still happening on day 1, we analyze the hydroponic system and the setup. The purpose of this part is to address the common misconception that plants are eating the soil. Having students see plants thrive in just water effectively moves soil to the eliminated with evidence column. In part 8, this is where we do the food indicators lab. We first want to start by making controls, our known food molecules versus the plain water to show both the positive and negative results. Then the students test the plant food or the hydroponics food for starch, glucose, and protein. We would then be able to compare the controls to our tests to be able to see that whole food molecules aren't present. A teacher tip. The students will use Benedict solution and iodine, both which were used in McKenna 7.3, but Burette and the brown paper test for fats are new. Because they trust the concept of food indicators from 7.3, the negative results in plant food create a huge cognitive dissonance. This brings us to part 9. And this is happening at the end of day 2, which is our building understandings discussion. The purpose of this lesson is to consolidate the finding that the below the surface inputs are not the source of the food molecules. Now, the kids might feel stuck here because we just eliminated the most likely sources, but this is exactly where we want them. Now, here's a great teacher strategy. Ask them, if it's not in the ground, what's left? What could we test next? So where do we go from here? This is our bridge. We've officially proven that there are no food molecules below the ground in the soil or in the water or the hydroponics food. On your candidates list poster, you'll want to move the sticky notes for soil and plant food from the candidates column to the eliminated with evidence column. This visual move is what creates the drive for lesson 3. If the plant isn't taking the food in from the roots, we have to investigate the only candidates left, air and light. Let's take a look at some tips and tricks that will help us move through this lesson possibly a little bit faster. All right. In parts 4 and 5, when we take a look at the hydroponic system, I can attest that this has been my problem before. I forgot to start the hydroponic system. No need to worry. If you didn't start it a month ago, don't panic. Just go to the store and buy vegetables like spinach or radish that already have roots on them and put them into your hydroponic kit. Just remember to wash off the dirt first. In part 8, let's talk about ways to organize this. Try a station rotation. To keep things moving, set up dedicated stations for complex carbohydrates, simple carbohydrates, proteins, and fats. Use color coordination. Color coordinate your pipettes to the cups. Remember to prep the samples. Some people have suggested to use baby food because it's already blended. Remember, if you're trying to use beans, use canned beans for your protein control because they're much easier to break down than dry beans. However, if your students read the hydroponic food label and determine that it doesn't have food molecules in it, you can move on. But this is a very fun lab, and I recommend keeping it. In part 9, there's a lot of questions on the Facebook group around how are we teaching how plants make protein if we eliminate fertilizer? I want you to remember we are eliminating the hydroponic food as a source of the direct food molecule. Later on, students will piece together that parts of things are coming into the plant that are used to build the food. But for now, what we are doing is just proving that they don't eat protein whole from the ground. So just eliminate it from now. We'll come back to that later. Let's take a look at the word wall management. In part 4, students officially earn the word hydroponics. In my classroom, students define this as growing plants without soil. It's a great moment to pause and define this as a class to ensure that everyone is using the same language. Poster management. There's lots of posters being created. In fact, there are 3 main posters that you're going to be interacting with. From Lesson 1, you'll need your initial consensus model. We explicitly reference this to look at where the kids originally suggest soil and water were inputs to justify where we are testing those as suspect first, why we are testing those as suspect first. You'll create a new poster called the candidate list poster. This is where we categorize our suspects into above the surface versus below the surface. You'll want to keep this poster as we refer to it a lot. Over the next few lessons, I keep this poster on my whiteboard. You will also make a new poster titled the Food Indicator Control Chart. This is a class reference for both the positive and negative color changes for the indicators. This poster can be discarded at the end of the lesson. So, to summarize, Lesson 2 is the big aha moment where students realize that plants aren't just green humans who eat their food from the dirt. If you remember one thing from this lesson tour, let it be this. The lab is about discrepancy. It's okay and actually a lot of fun when the students realize that the plant food contains no food at all. This is the essential bridge that turns your students into investigators who are desperate to know where the matter comes from. In the next lesson video, I'll take you through another large lab of the unit where we finally look at the above the surface inputs, air and light. That's all for now. Happy teaching.